Hi everyone. Notes 6.1 are on exponent rules. So at the top it says in multiplication, the terms that are multiplied together are called factors. Okay? And a repeated multiplication of equal factors can be expressed as a power. Okay? So examples involving exponential notation, we're going to identify the base and exponent in each expression. So here, what this is saying is 5 times itself 1, 2, 3, 4, 5, 6 times. So this means 5 to the power of 6. So the base is 5 and the exponent is 6. Okay? In number 2, it's 9 over 7 times itself 4 times. So that means 9 over 7 to the power of 4. Now you need to have brackets here because we want to show that the entire thing is being raised to the power of 4. Okay? So here our entire base is 9 over 7. And our exponent is 4. And one other thing I want to indicate too is this is called our power right here. Okay, so now for number 3, this time I'm giving it to you in exponential notation and you need to expand it. So negative 4 over 11 to the power of 3 means negative 4 over 11 times negative 4 over 11 times negative 4 over 11. So here the base is negative 4 over 11 and the exponent is 3. Okay, in the next one it's negative 2 to the power of 6, so it means it's negative 2 times negative 2 times itself 6 times. So my base here is negative 2 and my exponent is 6. All right, and then our last one here is 3.8 times itself 4 times. So what I end up getting here is that my base is 3.8 and my exponent is 4. Okay. Now, we're going to add on another question. This is going to be question number 5.5. And let's say 5.5 says negative 2 to the power of 3. This one's different because here our base is simply just 2. Okay? The negative is not part of my base. The exponent is 3. Okay, so what this means is I'm going to do 2 times 2 times 2 because my base is 2 with just a negative that tags along. So this negative only tags along. It's not part of my base because it's not in these brackets here. So do you notice that the brackets are used in questions 2, 3, and 4? And why do you think they're used? The reason why is because we need to indicate the brackets indicate the entire root. Okay? All right, so some quick vocabulary. The number x to the power of n is called x raised to the nth power, or to the power of n, where n is the exponent and x is the base. Okay? All right, so that's it for our first piece right here. So looking at number 6, we want to expand 10 to the power of 6 times 10 to the power of 3. So if I do that, 10 to the power of 6 means I'm going to multiply 10 by itself 6 times. And 10 to the power of 3 means I'm going to multiply 10 by itself 3 times. And when I multiply those guys together, I get 10 to the power of 9. So right here, if you notice, there was a 6 and a 3, and we ended up getting a 9 right here, okay? So looking at number 7, number 7 says a to the power of 2 times a to the power of 1. So a to the power of 2 is a times a, and a to the power of 1 is just a. So altogether, I'll get a to the power of 3. So we have 2 and 1 to give us 3. Here we have 6 and 3 to give us 9. So when you find the product of two algebraic expressions with the same base, you can just add their exponents and use this exponent with the same base. So in other words, a to the power of m times n is equal to a to the power of m plus n. Okay, so let's take a look at some of these examples here. So simplify each expression. The base is the same, so my answer is going to have the same base, and then I'm going to add my exponents. So 2 plus 3 is 5, so my exponent is 5. All right, in this one right here, the bases are the same, so I'll get 3, and then I'm going to add my exponents. There's an invisible 1, so 6 plus 1 is 7, so this gives me 3 to the power of 7. And then in our last one, same thing, our bases are the same. I'm going to add 23 and 9 together. And when I add those together, I get 32. So it's 8 to the power of 32. Okay? All right, so let's take a look at number 11. In number 11, it says 5 to the power of 6 divided by 5 to the power of 2. So 5 to the power of 6 means 5 multiplied by itself 6 times. And then in the denominator, it's 5 multiplied by itself twice. These 5's cancel, so I'm left over with 5 to the power of 4. So the question is, what do I do with the 6 and the 2 to get a 4? Let's do one more example. Y to the power of 7 divided by y to the power of 4. You get 7 y's on top, and then you've got 4 y's on the bottom, and when you cancel stuff out, you end up getting y to the power of 3. So the shortcut is to just subtract your exponents. So when you find the quotient, quotient means division, of two algebraic expressions with the same base, you can subtract their exponents and use this exponent with the same base. So a to the power of m divided by a to the power of n is a to the power of m minus n. Okay? So taking a look at number 13 right here, we have 2 to the power of 9 divided by 2 to the power of 6. They have the same base. And then I'm just going to do 9 minus 6, which is 3, so it's 2 to the power of 3. Okay, here I've got negative 7 to the power of 5 divided by negative 7. They have the same base, so I'm just going to do 5 minus 1 because there's an invisible 5 here. And when I do that, I get to the power of 4. This one is different. Take a look at this one carefully. These are coefficients, so you do normal division. They're not exponents. So you do not subtract these values. So 35 divided by 5 is 7. Now, this x to the power of 4 and x to the power of 2, I subtract those because they have the same base. I do not mix and match, so only do your x's together, and then we'll do our y's together, so we get y to the power of 4 because 7 minus 3 is 4. Okay, so now for number 16, it's a little bit more difficult. So what we're going to do for number 16 is we're going to do the numerator first. And since it's multiplication, we're going to add all of our exponents. So 2 plus 7 plus 1 is 10. So you get 4 to the power of 10. And in our denominator, 3 plus 1 plus 4 is 8. So you get 4 to the power of 8. So I did my denominator all together. Now I can divide these two. And when I divide, I subtract my exponents. So it's 4 to the power of 2. For number 17, same thing. I'm going to look at this whole numerator. And then I'm going to look at this whole denominator. So in my numerator right here, I have 1/4 to the power of 3 times 1/4 to the power of 1 times 1/4 to the power of 2. So here, this will give me 1/4 to the power of 3 plus 1 is 4 plus 2 is 6. All over, this will become 1/4 to the power of 1 plus 1 plus 1 is 3. So my final answer will be 1/4 to the power of 6 minus 3 gives me 3. Okay? All right, so for the next one, we're going to multiply all of our coefficients together. So normal multiplication for regular numbers here. So when I multiply those numbers together, I get 3 times 5 times 6, and I get 90. So in my numerator, I end up getting 90 for my coefficients. Let's do the same thing for my denominator. So I'm going to do 2 times 3 times 5. So 2 times 3 times 5 here gives me 30. So I'll get 30 in my denominator. Okay? Then I'm going to multiply all the variables that have the same base. So see how these both have x's here? So I've got x to the power of 4 and x to the power of 6. So that gives me x to the power of 10 because 4 plus 6 gives me 10. Okay, and then for my last one right here, or sorry, let's do the x's in the denominator. There's only x squared, so I'm going to put x squared down here. Okay, and then lastly in the numerator right here, we have y to the power of 3. So I'm going to copy that down because there's nothing else like it. And then here in the denominator here, we've got y to the power of 1 and y to the power of 3. So that gives me y to the power of 4. Okay, all right, so now that I've done that, I can just do my normal division. So I end up getting 90 divided by 30. It's just normal division. So when I divide 90 by 30, I get 3. So I get 3, and then when I divide, I need to subtract my exponents. So 10 minus 2 is 8. So I get x to the power of 8. And then I'm going to subtract my exponents here, so I get y to the power of -1. Okay? All right, so now for number 19 here, they all have the same base, so 19 is a little bit easier. I'm going to do just the numerator, so when I multiply, I add, so 7 plus 3 is 10, plus 2 is 12, so I get 6 to the power of 12. And in my denominator, 1 plus 4 is 5, plus 5 is 10, so I get 6 to the power of 10. And when I divide, I need to subtract my exponents, so 12 minus 10 gives me this 6 to the power of 2 right here. Okay? All right. Let's just take a look really quickly at number 20, and then we'll be done with these types of questions, okay? So for number 20, I'm going to do the same thing like what I did for number 18. So I'm going to multiply my coefficients together first, and it's normal multiplication. So 4 times 9 gives me 36. So I'm going to write down 36 here. Then I'm going to multiply my coefficients in the denominator together as well. And 2 times 6 gives me 12. Okay? All right, so now the next thing I'm going to do is I'm going to look at my a's, and I'm going to multiply those together. So in my numerator, I've got a to the power of 4 and a to the power of 3. And when I multiply, I need to add my exponents. So I get a to the power of 7. In my denominator, I've got a to the power of 2, a to the power of 2. So when I add my exponents, I get a to the power of 4. And then for the b values right here, I'm going to see I've got b to the power of 5. There's nothing else like it, so I'm just going to copy that down. And then I also have b to the power of 2. Okay, so 36 divided by 12 is 3. A to the power of 7 divided by a to the power of 4 is a to the power of 3. And then here I get b to the power of 3. And that's my final answer right here for this question. Okay? All right, so now let's go ahead and take a look at question number 21. Number 21 says, what does 2 to the power of 4 to the power of 3 mean? So essentially what this is saying is I just have to do 2 to the power of 4 times 2 to the power of 4 times 2 to the power of 4, because this says to do it 3 times. So 1, 2, 3 times. So right here, when I do this 3 times, I get 2 to the power of 4 plus 4 plus 4 is 12. So I get 2 to the power of 12. Okay? And then for this one right here, I get n to the power of 2 times n to the power of 2. And this is telling me I have to write it out 5 times. So when I write it out 5 times, 2 plus 2 plus 2 plus 2 plus 2 is 10. So I get n to the power of 10 for my answer here. Okay, so the shortcut that I can do for this is I could just essentially multiply 4 times 3, and that's how I get this 12 here. Or I could multiply the 2 times 5, and I could get this 10 here. So what do you notice? When you have a power to a power, just multiply exponents. Okay, so when you raise a power to a power, keep the base and multiply the exponents. So in other words, if you have a to the power of m times a to the power of n, it's a to the power of m times n. Okay? So let's take a look at what we have here. So number 2, I've got 15 to the power of 3 raised to the power of 9. So I'm going to do 3 times 9. And when I do 3 times 9, I get 27. My base stays the same. So this is saying I've got 27 15s being multiplied together. Okay? For the next one, my base is -2, and it's being raised to the power of 5, then to the power of 8. So 5 times 8 is 40, so I get -2 to the power of 40, and I need brackets around that -2 because it's a negative number that's being raised to this power. Okay? All right, the next one right here, a to the power of 17 to the power of 4. I'm going to do 17 times 4, and I end up getting 68. So this right here ends up being a to the power of 68. Okay. In number 25, we have a to the power of 3, b to the power of 3, and c to the power of 1. And what we're going to do is we are going to raise each one of these to this power right here. Okay, so I'm going to do for a, I'm going to do a to the power of 3 times 4 gives me 12. So it's a to the power of 12. For b here, I've got b to the power of 12 because 3 times 4 is also 12. And then for c, I get c to the power of 4 because 1 times 4 is 4. And that's my answer for number 25. Okay? All right, number 26 and 27 are trickier, so we need to be really careful about these two. So for number 26, same thing, I've got 2 to the power of 1. So this becomes 2 to the power of 1 times 6, which is 6. And then here I've got x to the power of 5 to the power of 6. So 5 times 6 is 30, so I get x to the power of 30. Okay, so here I'm going to do 2 to the power of 6. So I'm going to multiply 2 by itself 6 times. So 1, 2, 3, 4, 5, 6, and I get 64. So this ends up being 64. Because this is a coefficient, I'm going to actually evaluate what it is. But then I keep my base the same. This is different. Since this is a coefficient, we actually figure out what the value is. Here, this was a base. So we left it as 15. Okay, there's a difference between the two. All right, number 27, last one of these. 3 to the power of 1 to the power of 4 becomes 3 to the power of 4. And then a to the power of 7 to the power of 4. I do 7 times 4 and I get 28. So I get a to the power of 28. To figure this out, I'm going to do 3 times 3 times 3 times 3. And I get 81. So I get 81a to the power of 28. And that's my answer here. Okay? Now let's just do our summary really quickly, and then we'll be good to go for this right here. Okay? So multiplying powers, if I have a to the power of m times a to the power of n, I'm going to add exponents. So we get a to the power of m plus n. Okay, when we divide our powers, we know that we need to subtract exponents. So if we have a to the power of m divided by a to the power of n, we get a to the power of m minus n. If we have a power to a power, so if we have a to the power of m raised to the power of n, that means that it's a to the power of m times n, so we need to multiply exponents. Okay? And really quickly, if we have a power of a product or a quotient, right here, what this is saying is if I have a, b raised to the power of m, that means that we raise each individual base to the power of m. And if I have a divided by b to the power of m, we raise each individual base still to the power of m. Okay? And then when we add or subtract powers, there is no rule. You just need to collect like terms. So an example would be like 5x squared plus 7x plus 9x squared. 5x squared and 9x squared are like each other. You get 14x squared, and then the 7x just tags along. Okay, that's it. Let me know if you have any questions, and good luck with your problem set. Okay, have a good day.